Welcome back, everybody, and good morning. That's next in a series about Mass Timber Office Forum. Today is our engineering, and here is our agenda. Just click on a slide, Laura. So shortly, Ollie will introduce our panel, and we'll get straight into our Q&A. We've got some live questions to be asked as well, so don't forget to use the chat function to ask those questions, and we'll try and integrate them as we go through. If not, we've got a separate section right at the end of the session to ask those questions. If we don't have time to answer them, again, we'll answer them as part of our summary report, so every question will be answered at some point. And we have our usual poll questions to throw in the mix as well, to make sure you're all awake. So without further ado, Ollie, over to you if you want to introduce our panelists, please.
Yeah, thank you, Matt. Good morning, one and all. This morning we have 1 hour to talk with a best-in-class panel of structural MEP and acoustic engineers from some of the world's best-known engineering organisations. I'll start with our structural engineers on the panel today. Alan Dowdall is an associate at Ramble. Alan has been designing in timber for over 15 years as a structural engineer. He leads timber design within Ramble and has worked on over 100 timber buildings. Ramble work with all aspects of the market and have a client base ranging from developers to specialist timber subcontractors, which enables them to push the boundaries in timber and innovations. Andy Hain is the director and one of the founders of Hain Tillett and Steel. Andy has over 25 years experience as a London-based structural engineer, working on a diverse range of projects within the UK, leading architects and clients. Andy leads the timber focus group at HTS and believes the only chance we have of slowing climate change is through extensive reforestation and significant increase in the use of timber as a primary structural material. Gary Elliott is the CEO and founder of Elliott Wood Structural Engineers. He has been a long-time champion of reform in the built environment and believes that mass timber will play a leading role in meeting the country's future zero carbon targets. Kelly Harrison is an associate director at Whitby Wood. Kelly has worked on design of structure, members and connections of several large-scale UK office refurbishments, including the award-winning Republic Building and Gramophone Works, which is the largest UK glulam framed office building. Currently, Kelly is working on an exemplar multi-use timber building with Grafton Architects for the University of Arkansas in the US. Kelly is on the TRADA Advisory Committee and is a board member of TRADA, soon to be known as TD UK. She has spoken nationally and internationally and published a number of industry articles. In 2020, she was named one of the top 50 women in the WE 50 Women in Engineering Sustainability. Rob Partridge is a design director at AKT2. Rob is leading a diverse range of projects in the UK and internationally. He has particular interest in timber engineering and works across a broad set of typologies, including Newington Butts with Peabody, a residential scheme, Garden Moen Airport in Oslo, and Bloomberg Vortex in London. Lately, Rob is involved in many UK workplace schemes, utilising timber as a key component within the design and building on AKT's knowledge from Google London. Tim Snelson is an associate director at Arup. Tim has 27 years experience of delivering innovative structural solutions to landmark projects. He has designed a number of high-profile, fast-track timber buildings, taking timber into new market applications, including Sky's Believe in Better building and new film studios at Pinewood. Tim is one of Arup's global timber experts and has been championing low embodied carbon for over a decade. His book, Rethinking Timber Buildings, is the most downloaded publication from Arup.com. And representing our expert in the MEP on the panel is Michael Bevan. Michael Bevan is an Arup Fellow and Global Automation Lead for Arup. Mike has worked in the UK, US, Japan and Australia with many of the world's leading architects, spending several years co-leading the integrated practice Arup Associates to push the boundaries of fully integrated design. He has been responsible for numerous world firsts and award-winning projects for innovative designs that seamlessly integrate sustainability, wellness and pioneering innovation. Mike was involved in the world's first LEED Platinum data center, the first naturally ventilated television studio at Sky, and the first zero energy stadium in Qatar. As a digital leader, he has driven the adoption of BIM throughout the building sector and championed global collaboration to produce common data standards throughout the firm. His external advisory work with clients and institutions has established new approaches to digital building and led transformation in data standards across the industry. And last but by no means least, our expert in the important field of acoustics is Barry Jobling, a partner of Acoustics at Hawley, which is one of the largest and longest established acoustic consultancies in the UK, working across all sectors on projects from conception to completion. His team were again successful in 2020, winning 2 acoustic industry awards, notably one for their design of the Lafayette music venue in King's Cross, which sits directly below Pro recording studios and offices, and the other for a groundbreaking enclosure for testing aircraft at Cambridge Airport. In terms of timber and CLT constructions, Barry has been actively involved in projects for around 10 years, including student accommodation, educational buildings, and more recently offices, in particular the Timber Square for Landsec, where they have been engaged in exploring and helping optimize the fine details. As always, the G&T team would just like to thank all of our panelists for giving us their time and contributing to today's forum. Thanks, Matt. We're good to go.
Great. Thanks, Ollie. What a panel. It's going to be a good one today. Thank you so much for all your time, panelists, in advance. So, Ollie, let's make sure everyone's awake. We've got 2 poll questions today, so let's have our first one now. So, Laura, if you want to put the question up, and Ollie, if you want to ask the question.
Thanks, Matt. Okay, so first poll question for today. What is your biggest concern when it comes to engineering of your mass timber project? Is it design experience, capability and supply chain, flexibility of space in terms of spans, columns, etc., acoustics and dynamics, design life, durability? So please tick one of those, and Matt and I will answer the results in a few seconds.
It takes about 30 seconds just to get the answers in. Actually, it takes longer when there's more selection. The next question's a bit easier.
Any minute now.
There we go.
Right, so a whopping 31% said design experience was their biggest concern. Shortly with capability and supply chain at 24%, design life durability at 20%. But thank you everyone for voting on that.
Great. Right. Let's get going with some questions then. So let's start gradually, and we'll build up. So, as engineers, what are the benefits and limitations of working with mass timber? Let's ask Gary that one first.
Good morning, Matt. Good morning, everyone. Great to be here this morning. I think we all know some of the main benefits. Obviously, timber is lightweight, it's quick and easy to install and to fix to. You've got off-site fabrication with low or zero waste, and it's biophilic. And of course, it's cost effective, although I appreciate that may be slightly controversial for some of the QSs in the room. We've been obviously strong advocates of it for many, many years. So there are obviously some limitations as well. So fire and water are key issues that have been well documented. But a main block in our view is perception. It's difficult to talk about the benefits of mass timber without talking about embodied carbon, the circular economy, and design for disassembly and reuse. Really critical things. And if you look at the journey of a piece of timber versus concrete and steel, the timber absorbs, it sequesters, and then stores CO2. And whereas steel and concrete obviously produce it a huge amount of it at the right at the beginning of the process. Something like 15% of all man-made CO2 is caused by cement and steel production. We all know that timber releases CO2 at the end of life, but that might be 30, 40, 50 years ago. But we need to absolutely kind of reduce carbon now. We think that timber could be a major part of that. If we are generally to reach zero carbon targets, as many of the people sort of that are in the room, the theoretical room at the moment, by 2030, then and do that without offsetting, then we have to fundamentally change our habits. I believe that the use of timber in new construction, applying the circular economy principles and designing for disassembly for the future are key ways to achieve this.
Great, thanks, Gary. Good start. Tim, do you want to add anything to that?
Well, I think good morning, everyone. I think Gary's covered all the bases, but I mean, so I guess I'll just amplify a bit. When it's lightweight, it means you can use the timber in places that you can't use concrete, for example. So we've built a couple of timber buildings over rail tunnels and on rail bridges recently, and that plays to all the things Gary was saying about off-site fabrication and smaller craneage. So there's plenty of stuff that timber can do that heavier materials can't. But the downside of that is that the design's generally driven by floor vibration for most useful buildings rather than by strength, and that therefore needs a bit of thinking by the engineer. But if you've got anyone on this panel, you'll probably be all right. And if you want to expand on Gary's comment about biophilia, I think that is really important from a design perspective, because the use of a beautiful natural material obviously means that the architects are going to want to expose it, and the structure becomes an integral part of the architecture. So you start to develop the need for really integrated design, really good communication between the architect and the engineer. And one of the great things about timber is you can glue it, bend it, steam it, cut it into some really amazing and beautiful shapes. And you can even kind of knit it like we did at the Pompidou Centre roof. So yeah, you can do some really amazing things with timber.
Fantastic. That's great, Tim. Thank you. And then from an acoustics perspective, Barry, do you want to add anything acoustically? You're on mute, Barry, I think. Or unless it's me. Try again. They're working? No. Well, while Barry sorts that, Mike, do you want to add anything from an MEP perspective?
I think, well, much has been said, and hi everyone, nice to be here. Well, being part of a low carbon building is significant and makes us think as building services engineers what we can do to reduce our embodied carbon too. I mean, it's fast build and really easy to fix our stuff too, and to adapt and modify it. We built some really highly serviced buildings with timber, either whether it's part of the build or a completely timber building. It can be covered up. I mean, as well as being exposed, you can cover it up for hygiene whenever you need to cover it up for fire. It can be exposed. And this thing about the benefits for people is so strong. We did a topping out of a building, and the client and we were touching the surface of the timber, and you wouldn't get that with a concrete frame. You know, it is insulating and helps with thermal bridging. And from a services point of view, there are really very few real limitations depending on the building topology. And as with all buildings, we do think about integrating services and structures. It does have low thermal mass, but we found, you know, in the round, that's a limitation for an impact for only a few buildings of types and users. So really, you know, from a services point of view, limitations are few.
That's great. Thanks, Mike. Barry, do you want to try again?
So I'm hoping you can hear me. Yes.
Yep.
So that's a good start
Yeah.
for the acoustic engineer. You can't hear me. So, sorry about all that practice. I'd come back to the perception point, and the perception of timber and CLT might be that you know, it's acoustically challenging. It's going to be a lighter weight structure, and you know, with that there could maybe be more transmission of sound around the building through structure. Immediate response would be, look, we can make it work. The knowledge on acoustic performance isn't perfect, but you know, we've got a reasonably long list now of buildings around the UK and certainly internationally. Talked about student accommodation, educational buildings, and of course we're moving more into you know, into offices. And listening to what you know, the others are saying about, you know, laying out the clear sustainable benefits, for me as an acoustic engineer, you know, it's important for us to buy in to the use and to help that adoption. You know, there are limitations. You know, a CLT slab isn't going to be directly comparable to the concrete one, so we need to think about where it's best suited. And what we don't want to do as acoustic engineers is sort of defeat the purpose by wrapping the timber. I think Tim mentioned it earlier, that importance of exposing it. We don't want to come in and, you know, defeat that purpose by wrapping it in materials that make it perform, you know, better acoustically, but only to negatively affect the embodied carbon credentials. So I'll no doubt delve into some of the practical challenges and also the opportunities that I think that we've got for improved products. So yeah, that's it.
Thanks, Barry. It's a good intro. Thank you. So let's bring Andy and Alan in. So as a guide, what design parameters best suit a steel and CLT floor, a glulam and CLT floor, and an LVL and CLT floor? And can you also take us through typical grid sizes for a mass timber frame, just to get the juices flowing a bit more from the engineering perspective?
Okay, thanks, Matt. Morning, everybody. So I'll try and break this down a little from our perspective. Firstly, into what types of structural solutions are commonly out there at the moment for commercial buildings, and then secondly, what drives the choice between them over more familiar solutions like reinforced concrete, steel with metal deck, etc. I had a quick review earlier, and in our practice, we have over 2 million square foot of timber or timber hybrid office structures, either on site or on the drawing board right now. And of these, I reckon 95% are CLT slabs with either steel frame, which is probably the lion's share, or glulam frame. The other 5% are less common combinations, maybe using alternative framing like LVL or precast concrete beams and columns even, or perhaps on the flip side using concrete slabs with a timber frame. But as I say, in my experience, office solutions right now are far more commonly CLT slabs partnered with either steel or glulam frames. I think that's because you can pretty much bank all the key benefits of low carbon, aesthetically pleasing, lightweight, dry, fast construction, offsite manufacture, etc., with the CLT slabs alone. Secondly, then, what are the key design considerations that govern choice of arrangement and solution, and what works best when? I think firstly, there's the column grids. For us, the starting point is optimum CLT spans of up to 7.5 meters, because this results in 240 thick slabs or thereabouts, which roughly provides sufficient mass for airborne and acoustic separation between the floors with only minimal additional linings. So that 7.5 meters then gives you the primary beam centers, which is great, as it means you end up with far less beams and cleaner soffits than using thinner CLT or metal deck slabs, say. And then subject to reasonable depth, primary beams sensibly can span maybe 9 or 10 meters in glulam, and for maybe 15 meters in steel, probably both then limited by dynamic factors. So all in, for a all timber solution, a sort of 7.5 by 9 meter grid is pretty optimum, is what we find. Secondly, in terms of building weight, I'm not sure CLT is as beneficial as we think when comparing to lightweight concrete metal deck slabs, say, as thinner CLT often has to be supplemented with heavier cementitious boards for acoustics anyway. But CLT slabs comfortably outperform RC frames, and even with small weight savings, they can be critical when building over buried tunnels and infrastructure, as we just heard, or extending on top of existing buildings, say, which we probably all do a lot of. Thirdly, depth of construction becomes more important the higher you go, as differences are multiplied, and with only limited openings possible through glulam downstand, steel does tend to outperform timber on this front. However, with CLT, the larger fresh air supply tends to end up in the raised floor anyway to make the most of the soffits and the attractiveness of them, so big beam penetrations aren't really necessary. And all of our glulam frame buildings at the moment, we tend to have the CLT sat within the depth of the primaries, so they actually compare really well with steel anyway. So I think, to summarize, in my opinion, what's driving the current market growth is low carbon, which glulam framing wins hands down over steel. So unless very large spans or really tight floor build-ups are critical to a scheme, I'd say timber frame with CLT slabs ought to be preferable over a steel frame, although I don't think that's being recognised in the market just yet.
That's great. That's a great answer. Thanks, Andy. Alan, would you like to add anything to that?
Yeah, sure. I mostly agree with Andy there. In terms of setting out the grid is usually the key thing, of what the spacing of that is going to be. It also usually ties into how the servicing strategy is working along with that, because, like Andy alluded to, actually, glulam beams can be deeper, and trying to punch holes through them, timber doesn't tend to like that so much. Thinking about the materials, CLT, yeah, 7.5 meters, by 9 bay is sort of probably where you're talking about the maximum grid layout on an old timber scheme. So just reinforcing what I said earlier. I'd say if the difference between, if that's glulam and CLT, if you're adding LVL into the mix and you're going taller, LVL is stronger generally than glulam, whether that's softwood LVL or hardwood LVL. So that really helps if you've got columns, big columns, you want to try and reduce them a little bit. It's not as stiff, so you don't get as much saving on the beam depth. You get a little bit, not as much as you might think. Where it comes into its own is that you can punch holes through it a bit easier. Only small holes a little bit more, but you get a little bit more advantage on that. So there's very little difference in the floor plate from LVL and glulam. moving into the steel option, you are possibly then looking at extending the size of your grids. That's a fan of that. I think as an industry we need to learn to use smaller grids a little bit, because that's where we're going to have the embodied carbon saving. So I think the future of office buildings isn't the 10, 15 grids. It's going to come down to the 9x6s kind of thing. I think that's where we should be selling that, because it actually, when you look at the plan of that, I think it's okay. You know, you got a spacious arrangement with that. Cool. Yeah, again, like I said, heights kind of things, so just the glue lamp depths, and as you go higher, also fire and things come into it a bit more. It becomes a bit more difficult to do it. The where we're seeing things at the moment is, like I said, the steel frame and the CLT. So there's hopefully in the future we can start to move into all out timber schemes.
Great. Cheers, Alan. Okay, let's bring Kelly and Rob in. So when designing mass timber projects, how have you found compliance with BCO standards? So Kelly, if you'd like to take that one first.
Oh, morning, Matt. Hi, everybody. Yeah, I think BCO is quite prescriptive, and probably the most difficult requirement I found when looking at timber buildings in particular, sort of glulam frames, is the floor vibrations criteria. So it asks for a maximum response factor. Response factors are derived from methodologies which are suited to sort of heavy mass floors, and they don't really suit timber structure, which creeps and shrinks, and also it also absorbs vibrations differently. I think sometimes the way vibration is calculated can be very, very subjective. Different engineers take different approaches all the time, and you know, it's quite intuitive as well, which isn't great for timber because it's a relatively new technology, and we don't have the same intuition for it. So at the moment, with the methods we have to analyse response factors, I'm not sure that I'm not sure it's possible to prove a long span timber structure. That doesn't necessarily say it's going to move more or you know, have a bad response. It just means that we've not got there to a point where you know, we're comfortable with it, I don't think. And I think we should be learning from the Austrians, really. Their national annex is the best for this sort of thing. They have a limit on accelerations and the natural frequency of the structure, and that's what I normally use to look at this, rather than the response factor, which BCO requires, which actually then ends up meaning that we don't meet by BCO criteria. So I think that's something that should be thought about a bit more for timber structures.
Thanks, Kelly. Rob, anything to add on that?
Morning all. Yes, I totally echo what Kelly said there about the structural kind of side of the BCO specification and vibration driving. But I think the other thing I wanted to talk about was the aspect of design. So obviously, as if we're going to use timber to kind of, you know, build our offices of the future, those spaces are going to look different. Things are going to change. The look and feel of those spaces is going to change. As Alan and others have said, grids will change. The soffits will change. And I think at the moment, you know, we're used to kind of decades and decades of offices designed and driven by steel and concrete. And I worry that sometimes the industry sort of tiptoes around this little bit, and we try and squeeze timber into a thin floor slab because that's what we need. That's what our commercial developers want us to do, right? Or if it's the downstand beam, I think Alan already said it, we try and punch holes through it. And timber doesn't like this. Timber wants to be free, it wants to be deep, it wants to be layered. You know, if you look at the historic architecture of Japan and China, you know, the timber buildings and structures, they're all layered. They're not squeezed into these thin zones. So I think that, you know, what we think of kind of, you know, office typologies at the moment and grids, all the things that kind of underpin the BCO specification and all other industry kind of views, as I say, it is all driven by steel and concrete design. So I think if we're going to succeed, we probably need to make sure that the BCO and others embrace the fact that the office is going to look very different.
That's great. Thanks, Rob. Totally support that as well. Okay, let's get some quick fire questions in. So, Gary, Rob, what would you say is the key design issue when it comes to building with mass timber from your perspective? Gary, do you want to take that one first?
Yeah, sure. I mean, I think without any doubt, I think it has to be fire, and particularly if the timber structures are exposed. I think there's been a lot of noise clearly over the last year or so, and it's been quite a journey, I think. And everybody on this table has kind of been going through a journey, quite a challenging journey, to demonstrate self-extinguishment and showing that the fires effectively go out without suppression or without the fire brigade intervening. I think we're going to probably talk a little bit more about that later, so I won't dwell on that right now. But in addition, and others have touched on this as well, things like deflections, vibrations, acoustics, water damage. These are all additional issues as well that have come up. And whilst those absolutely have to be dealt with, they are kind of in our control. And they may be difficult, but they are within our control. And they're also issues that clearly we have to deal with all materials and all structures. So it's just a process that we need to go through, and there may be a little way to go in terms of the sort of detailed understanding of vibrations, for example, but certainly they're all sort of manageable. I think it's true to say that timber construction and buildability issues, clearly are areas that have been talked about quite extensively on this series, and covered in previous sections. But I think the detailing, from a structural perspective, the detailing of the connections in particular are absolutely critical in design. And experience and knowledge of areas like sort of facade and floor construction, absolutely critical in terms of heat gain and how we kind of deal with pyrolysis in the timber. That's the weakening of the timber itself. And then there are kind of issues, I think, about the way that we design with respect to the base build. So we're designing a building, which is sort of obviously the main structural content. And timber buildings can be impacted by the things that you might do to a building during a fit out. So breaking the compartments down, putting new staircases in, things like that can be really challenging. So I think one of the things that we've been promoting is a kind of tenant fit out guide, something that it kind of actually comes with the building once you've kind of completed the structural works, to make sure that those elements are not compromised.
Great. Rob, do you want to add anything to that?
Yeah, I mean, Gary's and of everyone else on the panel has probably already summarised what the key design issues are. I think I'll kind of flip the question on its head and say what Gary said as well, which is that we're all structural engineers on this call. We understand that every material has pros and cons, right? And that's what we like. We solve it, right? That's what we do. And I think what I'd like to say is that there are quite a lot of solutions out there which we should all be proud of. Andy's already talked about hybrid structures. I think the whole every material has a pro and con means that often we're not going to build just in timber. That's the wrong answer. Sometimes it's the right answer, but other times we're going to combine it with other materials, and we're all doing that across many projects. The other interesting thing is we're all doing some really interesting schemes and developments across the world, which are very innovative and they haven't been done before. They are effectively like test beds and prototypes, right? We're all doing them, all our companies are doing them. And I think that we need to continue to learn from all of these projects and pull the data. I think that's not talked about enough in our world. And the other thing is material science, which again we could all talk about for hours, I'm sure. But just simple things like using different species of timber, combining hardwood and softwood, which we did in the Maggie Centre, which just means that the disadvantages of vibration and stiffness that others have talked about, are enhanced because you're using material in a more efficient way. So I'm hoping that we're going to start talking less about the design challenges of timber and more about the fact that we've all got the solutions going forward.
Great, thanks for that. So just a couple of quick ones before we get into our next poll. So Alan, just a quick one on how you approach dealing with deflection and frequency on mass timber buildings. Can you just give us a quick answer on that one?
Quick answer. I'll write a PhD on this, I think. Deflection's quite easy, really. Like Rob was talking about, we're designing to a problem, we can get a solution. Deflection will have the same performance as any other material, really. In fact, actually, glulam, you can pre-camber it and take advantages of enhanced its performance with the deflections on that. And it's quite easy to pre-camber glulam, so you're getting it for pretty much free. So why not do it? Frequencies are a bit more tricky because you're dealing with I suppose, perception, and it's a bit more of a grey area in terms of what's like for vibration of a floor. I'd say, on a floor plate, you want timbers are lightweight. You want to have a high frequency compared to probably low frequency on a heavier floor plate, to sort of, so you're not resonating with the frequency that people tend to walk with. And then you get into the response factors, things about floor, what the acceleration of that step is when you take it. And I think Kelly alluded to earlier, you're dealing with a lightweight floor, which is different than the heavyweight floor. So there's a different mindset put in there about what the different type of response that you get, and understand it. I think, John, as a consultant in the industry, we need to be talking more to our clients about vibration. We don't seem to just put it into a report and say, yes, fine, because we did some numbers. We're actually, you want to be, taking your client through that and say, look, here's the places that have got a little bit of a spike, and here's the places that are really, really good. That's irrespective of material. And then you can work out the opportunities and the benefits that can come with that, and where you can place things. And that's exactly what we do with lab buildings. So we should be taking that sort of principle and bringing that into our office spaces, and then we can talk to the client and add value to it that way by not over speccing the material. We've got just to hit an 8 factor on the BCO document. That's generally the feel.
Cool, thank you. So just to link in one of our previous sessions, in fact our last session with the suppliers and the subcontractors. So Kelly, can you explain how your practice deals with the trade, i.e. the supplier and the subcontractor throughout the design stage? Just a quickie on that one, if you could.
Problem. Yeah, I think I've worked with all of the suppliers from the last session. They're extremely helpful, and they're really willing to give advice at early design stages, even at competition stages sometimes when we've not even won jobs yet. And really with all off-site modern methods of construction, not just timber, I think it's important to engage with the suppliers early doors, because where your site is, the transportation logistics of getting there, the storage they have on site, the access that you can get, depending on what's around it, all affects the solution that you're going to go with, and what products are most suitable, and how we can get the most innovation and the most sensible solution, really. And I think also, I don't think we've talked about it yet, but also, water management plans and understanding how we're going to control that through the build is really important to think about at the start as well, and how your connection detailing might work to make sure that water doesn't pond or get into the end grain of your members. You have to be thinking about those things right at the beginning of your design process in stage 2, stage 3. And I think they're really willing to do that. And I think it really benefits the project when they are on a PCA early doors to help us with that as well, because there's things that we can't know about, how they might load a truck, or how they might store the materials at another storage point near the site, and then bring them one by one as they're needed. You learn those things as you go, but different suppliers do it different ways, different sites have different issues, and we need to think about all of that. And also when they're super helpful when you have these innovative ideas, as Rob was talking about earlier, there are different solutions out there, there are different materials we can use, but sometimes as engineers we get very excited about these, and we need bringing down to earth by the suppliers to make sure it's actually buildable and you can procure it. So yeah, I've found when that's been the case, they've been really helpful as well. So I think it's a great industry to work in, because everyone wants to move together forwards, and so I find them extremely helpful, and yeah, would definitely recommend having them on a PCSA early stages of a job.
Thanks, Kelly. Thanks for that. Ollie, do you want to do our second poll question, please?
Yes, please, Matt. Okay, right. I think this is a really fundamental question. So, in your opinion, should there be more regulation that focuses on embodied carbon? And this is a yes, no, or don't know answer. So, I mean, regulation is quite broad. I mean, that could be government, planning, GLA, it could be BCO, it could be assessment methods. We've all talked about how important, you know, getting to net zero is. All our organisations are very conscious of it. So do you think there should be more to highlight it, to perhaps reward it? Or do you think we're already there and actually everyone's spot on with this? So if you could tick one of those three, please, we'd much appreciated.
Okay. Drum roll.
Okay, going through now. Wow, okay, so a whopping 91% said yes, which I think is a pretty powerful message that we'll pick up in the white paper at the end. But I think that says a lot, Matt. That's really quite a powerful message.
Agreed. Great. Right. So next question, that leads in nicely, actually. So measuring embodied carbon and carbon offsetting is a hot topic at the moment. Who is best placed to do this, and what guidance and criteria should we all follow for consistency? Kelly, do you want to pick that one up first?
Sure. I mean, in my opinion, we hold the structural BIM model. So it makes sense for the structural engineers to be measuring that embodied carbon. I think at the moment, every company has their own carbon database that they use and they've developed. I think there's work being done by the IStruct at the moment to kind of, I know Gary's been working with them to harmonise that and bring out a more standardised version that we might be using later in the year. But I mean, in terms of carbon offsetting, I do worry, I mean, great idea, but I don't know how that fund is then spent. And I worry that it's another linear solution to when we should be thinking about circular solutions. And it's just dealing with another, you know, a linear process of building a building and offsetting it. Whereas maybe, you know, we're engineers and we're problem solvers, and it'd be great to think more about how we can make the whole process more circular. How can we reuse existing building stock? How can we, you know, maximize the capacity of that building stock, and extending in lightweight materials is the perfect solution, in my opinion. Sometimes that existing building stock isn't the most sustainable. It depends on the envelope, on the structure, and the M&E solution as well. And so if that proves to be the case, how can we look at our demolition specifications to reuse that building stock in a better way on another site perhaps, or in the new build, or if that's not possible and you know, economical, how can we make sure that it's recycled properly and responsibly? And I think that they're the really important things that we should be focusing on at the moment. Yeah.
Thanks, Kelly. Andy, would you like to add anything to that?
Yeah, I agree with Kelly. I think at the outset, structural engineers are probably best placed, you know, when we're doing optioneering and so on, to assess the carbon, embodied carbon of a structure. And then maybe a bit later on when you have to start talking about sort of offsetting and looking at more holistic life cycle carbon in terms of, you know, operational energy and end of life and so on. I think a dedicated kind of sustainability consultant probably is best to look at it in the round. I just wanted to sort of touch on a few sort of carbon figures that we've been carbon counting using our sort of built-in tool we've got for Revit for 5 or 6 years now, and benchmarking our project database of over hundreds of jobs. And it's taught some interesting things. I mean, for example, CLT slabs are roughly 50 kilograms of CO2 per square meter, which is about 30 or 40% saving on metal deck slabs, and a glulam frame is also roughly about 50 kilograms of CO2 per square meter, whereas a steel frame is probably at least double that, and especially if it's you know, in combination with CLT slabs, where you don't get the sort of composite benefits of a metal deck slab or something. So overall, steel and CLT is probably around double the embodied carbon of an all timber frame, with RC frame actually somewhere probably in between. So I'm a massive advocate of total timber, and it's maybe a little controversial, but I'm more cautious about a steel and CLT combination if it's sold largely on a carbon basis.
Cool. Okay. That's really interesting for our stats. Thanks, Andy. Mike, Bevan, so can timber and CLT frames still be used as a heat sink, or does this require additional provision? Is it needed for fire and any provision in carbon in terms of carbon terms to achieve carbon neutral positive building? Mike, do you want to pick that up? Mike, you're on mute, sorry.
That's an interesting point. And the thermal mass can be a useful thing. It requires quite a lot of organisation to tap into it. So, you know, opening windows, cooling the structure overnight, that kind of stuff. So you need to work hard to harness those energy and potential comfort benefits. So when a building is mechanically cooled or mixed mode, in terms of total carbon, the energy savings by thermal mass are actually quite modest, particularly when you include embodied carbon in that calculation. And we found that well insulated and airtight constructions are of greater benefit for most buildings and its users. And picking up the previous conversation about the embodied carbon of structure, the facade can contain an awful lot of aluminium and high grade metals, that kind of stuff, and really bump up that embodied carbon calculation, particularly when the rest of it is being addressed in terms of timber and low carbon solutions. So the size of windows we use, the orientation, the light, the balance of the facade is a bigger contributor to comfort and to energy use. And where you can actually use solely natural ventilation and get rid of the MEP systems, essentially, so then you have a radically lower carbon footprint. But again, and then thermal mass can be a key thing to make that happen. We can apply either thermal mass or virtual thermal mass using eutectic or phase change materials, and you know, phase change plasterboards are developing all the time. They have their own issues, but we can perhaps have a timber frame building with thermal mass exposed to the room to give that benefit while still getting the embodied carbon benefits of timber. So, but thinking about the whole joined up bit and the actual reality of how much thermal mass you need. So I think there's it can be useful in certain circumstances. For most buildings, we found thermal mass to be not as important as sometimes the press would have it.
Great, thank you very much. I'm going to move on to durability. Tim, just picking up on design life, and does design life differ between timber buildings to steel and concrete? I'll pick that one up for us.
Yeah, sure, no problem. I mean, I think most people have alluded to the idea that the design requirement shouldn't vary with the material. So that's the performance requirements should be the same, a serviceable building. The sad thing is that most buildings that have been designed during our careers haven't made it to their design life, not even halfway there. In the UK, and particularly in London, we're guilty of demolishing buildings after 10 to 20 years when the first lease is up. And that's an embodied carbon disaster. So, you know, this, as Kelly was saying, keeping buildings and making best use of them is a key part of our sustainable future. But, you know, just to say, I don't think the design life of timber needs to be any different to concrete or timber. There's plenty of medieval timber buildings in the UK and older that are still going strong and still doing fine, and they follow simple principles of keeping the rain off and keeping the ground-borne moisture out. So we have a kind of a saying in Arab that you give timber a big hat and a solid pair of boots and it'll be fine. So just as steel buildings need protecting from rust, timber buildings need protecting from rot, and that's the bottom line. Yeah, if you keep the timber dry, it can last 50, 100 years or more, and that's where the water management plans are absolutely essential. During the construction process, keeping the timber dry, managing the water, making sure you can get rid of it. But another key consideration that maybe people don't always think about, you know, a lot of the suppliers that you had on the previous session, they're well trained in moisture management plans, water management plans, and so on. But then they knock the frame up super quick and leave the site. And it's really important to keep that water management plan running until the building is totally weather tight. And that's actually where most of the problems come in, when the structure's built and it's then the facade and the roofing that are coming along later and slower. that's when the timber mostly gets wet and when you can lock it in under your membranes and so on. So my big plea, I think, for design life and durability of timber is to keep your water management plan going for the whole of the project.
Thank you for that. Okay, in terms of MEP then, what should we be considering from the outset when pursuing mass timber offices? Mike, do you want to pick that up? Obviously, MEP wise.
Sure, thank you. Yes, yeah. So, Robert, not all structural engineers here. I'm an MEP engineer. So, one of the things I think we need to think about MEP is timber buildings can accommodate a whole range of MEP solutions. There's no magic in it. But to think about how we design and integrate systems and building services systems in particular from the outset anyway, and our integrated way of thinking, our integrated working to thread systems through. But really, apart from me, I think it's also thinking about the benefits and characteristics of timber. So cassette facade systems can be very airtight, very highly insulated, very low thermal bridging, and using that as a kind of to eliminate perimeter heating systems if we can, or use that to really exploit the benefits to make our MEP systems better in a sort of integrated way. I mean, there are issues about, as described, timber doesn't like big holes in the beams and so forth. And I think with a timber building, with exposed timber and this new way, the environment of having a kind of a perception of timber as a healthy building thing, healthy buildings, post-pandemic design, we're thinking more and more about underfloor supply for air, upwards distribution of air and taking it away, and full air systems. So it's working kind of hand in hand with a healthy buildings philosophy to have the exposed soffit, fewer services at high level and air supply through the floor. Although to be clear, you can have high level building services with a timber solution. Again, planning those, any big ducts needs a bit more kind of thought before you stick it through a beam. So I think plan again with all things planning ahead, thinking about the natural way that timber works, the natural way we want to make airflow to work, can make them symbiotic, work together and give really great buildings that do all the things that users need them to do. And critically, it doesn't limit what you can do from a building services point of view, but you may want to have some more symbiotic ways of putting the things together.
Great, thanks, Mike. I've got a number of other questions, particularly on fire as well. However, we've had a number of questions on acoustics. So what I'm going to do is bring Barry in. I'll start the ball rolling on acoustics. Barry, ask you a question on that, and then it may be that in answering that you've answered some of the other questions that we had coming in. So what are the things to consider from an acoustics perspective on a mass timber building, and how do you overcome them? And I think you might answer a number of other questions that have come in answering that one.
Yeah, I mean, there's definitely been overlap when we're talking about vibration, and I'm definitely going to pick up some of these issues again. I mean, I think to help the developers that are looking at mass timber and CLT, there's probably two things that I think I would offer up to support the thinking and planning. I have to be fairly quick here, conscious of time. The first one is probably a bit tacky, but bear with me. It's available and reliable data, and it was something that was mentioned very briefly earlier. I think Rob had picked it up. Acoustic performance data, how much sound reduction does a basic timber slab structure provide? How does vibration transmit through the structures? I know it seems like we should have that. We don't. It's not. It's far from perfect. And I was actually talking with one of our younger engineers about this morning, and he said, do you know what CLT stands for? Causes loads of trouble for me, which I sort of find in an engineering way sort of funny. And he wasn't it wasn't that he's stuck in the past or looking for an easy life, but the reality is that data available to us from the past has been limited, and with that there's uncertainty. And with uncertainty, there's the risk that we go down the path of over-engineering, which I've seen, wrapping CLT cores up to the point that the actual acoustic benefit of that core is sort of, disregarded almost. The data, I don't want to knock it too much because the data has improved, but it's not comparable to the likes of the dry lining suppliers, who have, I guess, through regulation, up their game and provide what it is we need to deal with the design. So we need that good data on the basic forms to allow us to do the modeling of site specifics, and we need the good data of not just the basic structures, but also the compositions. So, you know, CLTs with a raised floor and no ceiling. What does that combination actually give us? So I think if we're going to build that confidence and accelerate the adoption, which I mentioned at the front end of timber materials, we need to be encouraging the supply chain to run the tests and provide the data, so that, you know, we can help to work with these guys and optimize the design and specification, so that the acoustic quality isn't downgraded. We don't just put up and it meets the end user's need. So the second one is a little bit quicker, but it is a big one. Important to consider flexibility. CLT, again, this has sort of been touched on, but CLT won't alone do the job for all situations. It's not directly comparable with concrete. You know, and you probably have heard acoustic engineers talk about mass. That's not the only defining characteristic, but you know, it's an important one, and broadly it sort of affects the sound reduction performance, how much noise stopping the timber provides, particularly at low frequency, and it tends to let more of the thud and the bass through. And I think, you know, this is, for me, this is really important for us to think about if we look at the future landscape and what our offices might actually look like. You know, we'd already been seeing a real mix of different uses in offices, with, you know, gyms, auditoria, entertaining spaces, even the odd TV studio. So, you know, if that's what the end users might want, I think we need to be very mindful of the limitations, and you know, it's not to, again, knock CLT. We can make it work, but we need to be aware of the implications, the potential need for enhanced floor coverings or ceilings or independent wall linings to actually enhance the sound reduction performance. We need to, as acoustic engineers, be mindful of the materials that we're coming to the table with to achieve that enhancement. And yeah, it's no good us kind of spoiling the party with advice that, you know, we cover stuff up with heavy cement-based materials. That just goes against the whole sort of business case in the first place. But I think, just finishing on the point that was picked up earlier, space. So if we are thinking about flexibility and how spaces might change in future, we need to be mindful that either we put the space provision in early on to allow for additional measures to be provided, or we go a bit further and provide, you know, a higher sort of starting performance. So yeah. Does that cover the acoustic challenges for now?
A number of the questions that we've had coming in there, Barry, but there are some other ones as well, but we are running a bit short of time. But what we'll probably do, as we normally do, is pick those up as part of our summary report and get you to answer those as part of that, if that's okay. So with time in mind, what I might do is just combine the well, a couple of questions I was keen to ask, actually. So if I could have sort of 30 seconds from everyone on what you can learn from international projects, and indeed what you see as being the changes that are going to happen with mass timber over the next sort of 5 years or so. I don't know if people want to just come in. So Gary, do you want to kick off with that?
Yeah, I mean, I think there's probably others on the table that've got more experience kind of on overseas. But I think the main thing is that timber is absolutely going to have to be a part of our future. You know, throughout the UK and throughout the world. And I think, you know, if we just look at, you know, concrete, for example, I know there's lots of sort of moves at the moment to try and sort of develop concrete and make it sort of more sustainable, but it's absolutely not the case. The only material that actually will reduce carbon now is timber. And I think, you know, we've got to make sure that this gets become mainstream and we deal with the kind of technical issues that are in front of us.
Right. Cheers. Kelly, do you want to pick up on international as well?
Yeah, sure. I've been working in the States recently, and it's interesting. They've got a very prescriptive code there compared to ours, and they have dead fast rules, and it depends on what state you're in and which version of those rules you use. but they're also much more open to new ideas. So if you want to do something innovative and you want to do some testing of that particular connection or arrangement, that's your liability. You get on with it and you do it, and you can use it. Whereas I feel like over there they invest very quickly in new technology. So they've built loads of CLT plants, but then they've kind of realized later that they don't actually know the best way to design with it yet. So then they sort that out later. Whereas I feel like in Europe and the UK in particular, we spend a lot of time sort of working out all the challenges and thinking of all the solutions before we actually invest and go for it with something. So I think that's the big difference between the States and here that I've noticed, and perhaps we could learn from. Yeah.
Rob, anything on that?
Yeah, when we did Oslo Airport, the roof structure was kind of driven by the kind of requirements of the prefabrication in the factory, and we looked at quite a lot of more expressive structures. And as Kelly said, we were brought down to earth by the constraints, right? But last year we did a studio for Harvard called Mass Timber and the Scandinavian Effect, and this is exactly what Kelly just said. One thing that came out of that, right, was that the question was that, are we constraining ourselves by actually working towards and with the requirements and constraints of fabricators? And is the architecture that's coming out kind of driven down quite a narrow sort of design path? Whereas actually, if we turn away from that, are we going to be more expressive? And I thought that was quite an interesting question to ask. So in the future, maybe we'll be more expressive.
Thank you. Alan, anything to add?
Yeah, I'd say that from my experience in the Nordics, there's a little bit more freedom in terms of grid setting out, and maybe you can fit that into the production level that Rob was talking about. They've been doing off-site for some time, so they're used to working to that sort of capability. I'd say learning is both ways, so not just rigidly sticking to what we've done, learning from there, but I think they could learn from us as well, in that all of their codes and regulations tend to be very prescriptive, and there's less engineering involved in it. And I think if they're on a journey as well in terms of zero carbon buildings, they put a lot of stuff into their buildings to meet a high regs that are suited for a concrete material. That I think they'll have to learn to tweak them in the coming years, which there are signs they're doing now already. So there's always going to be learning both ways. I think we should all learn from each other, really. And I think there was a comment earlier about sharing information and data. And I think if we're going to really accelerate the uptake of timber, then sharing data from all practices and engineers is going to be what's going to help drive that.
And Tim, 30 seconds from you.
Yeah, I guess Kelly made the point about more detailed guidance. The UK really suffers from a lack of detailed guidance on how to design timber buildings. Certainly our European offices have seen a major uplift in timber projects, and certainly they benefit from having that increased guidance, and also the testing that Kelly was talking about. I mean, our Amsterdam office, a large proportion of their work is now timber, or more accurately to say hybrid, because most of these countries will require you to put concrete cores in the minute you get above 3 stories. So why don't we just do that sort of thing in the UK? And I think the idea of, they're much more comfortable with hybridizing stuff. And I think that is a challenge for the way UK contractors procure things, because we've all talked about how timber buildings can be made really efficient by teaming them up with concrete or steel, but that always seems to create a bit of a challenge for a UK contractor, because they're not really general builders so much nowadays to actually procure. And that's really where a lot of the future is going to lie in timber, is solving the problems by using the right material in the right place.
Great, thanks, Tim. That's a great way to finish, I think. So thank you all to our panelists. I mean, that was a fantastic session. We've got a number of questions we haven't answered, so we'll wrap those up and in our summary report with you, just to make sure our audience receives all of those. And then our next session is on sales and leasing next month. So look forward to that. But that is it. And thank you very much for joining us, and we'll see you next time. Thanks very much. Take care.